Hi everyone, welcome back to Teaching Math. You've made it to the final part of Scientific Notation series. Awesome job. Today we're bringing it all together by exploring real-world application of scientific notations. You'll see how these math skills help scientists, engineers, and even computer programmers make sense of huge and tiny numbers every single day. Let's dive in. So when you deal with numbers that have dozens of zeros, scientists use scientific notation to keep everything clear and readable. So let's take a look at this example. The distance from Earth to the Sun is 1.5 times 10 to the 8th power kilometer. And the distance from Jupiter to the Sun is 7.1 times 10 to the 8th kilometer. How much further is Jupiter from the Sun than the Earth? So, well, what do you think we should be doing? Adding, subtracting, multiplying, or dividing? Because it's asking how much further is Jupiter, that means we're talking about the difference in distance. Therefore, to solve this problem, we have to subtract the two distances. Let's go ahead and do that. 7.8 times 10 to the 8th power minus 1.5 times 10 to the 8th power. If you remember from our previous examples, when we have the same exponent, we can simply subtract the coefficient. 7.8 minus 1.5 times 10 to the 8th power. 7.8 minus 1.5 will equal 6.3 times 10 to the 8th power. So the Jupiter is about 6.3 times 10 to the 8th kilometer further from the Sun. And that means 630 million kilometers, a huge number that's easy to read thanks to scientific notation. Example 2, the size of an atom. A hydrogen atom has radius of 2.5 times 10 to the negative 11th power meter, and an oxygen atom radius is 6.0 times 10 to the negative 11th power. How much larger is the oxygen atom? So here's our question. Again, we're looking for the difference. Therefore, to find how much larger is the oxygen atom, we have to subtract. 6 times 10 to the negative 11th power and minus 2.5 times 10 negative 11th power. Our exponents are the same, so go ahead and subtract the coefficients. And the answer will be 3.5 times 10 to negative 11th power. 3.5 times 10 to the negative 11th power is our final answer. The size difference may seem huge at first in atomic terms, but both atoms are unbelievably small. It's like comparing two grains of dust floating in galaxy. These are so small that you need a super powerful microscope just to see the difference. Example 3, technology scales. A computer processes 3.5 times 10 to the 9th power operations per second. The question is, how many operations does it complete in one day? Here's how scientific notation shows up in technology, and why in here we will multiply instead of adding or subtracting or even dividing. This problem says a computer does 3.5 times 10 to the 9th power operation every second. That means in just 1 second, it completes 3.5 billion operations. Wow. Now, the question asks how many operations does it complete in the whole day? Let's think about that. If you know how many operations it does in 1 second and you want to know how many it does in 1 day, you will have to find the total across all seconds in a day. We could add 3.5 times 10 to the ninth power over and over again. But there are 86,400 seconds in one day. 86,400 seconds in one day. And that would mean adding 3.5 times 10 to the ninth power 86,400 times. That's a lot of adding. So therefore, we would use multiplication, which is going to be faster way than repeated addition. So instead of adding 3.5 times 10 to the ninth power over and over, we multiply it by the number of seconds in a day. There are 86,400 seconds, which is written in scientific notation as 8.64 times 10 to the fourth power. So let's go ahead and multiply 3.5 times 10 to the ninth power multiplied by 8.64 times 10 to the fourth power. You remember the rule for multiplying numbers in scientific notation. We multiply the front number, which is the coefficient, and then add the exponents. Let's do it step by step. Multiply 3.5 times 8.64, and then add our exponents, 9 plus 4. That gives 30.24 times 10 to the 13th power. But wait, 30.24 isn't between 1 and 10, so we need to fix that. So let's move the decimal 1 point towards left and then multiply by 10, and then at the end, for final answer, add the exponents. Times 10 to the 14th power. Final answer is 3.024 times 10 to the 14th power. That's 302 trillion operations every single day. In regular form, that's a 3 followed by 14 zeros, just like this. Now you can clearly see why using scientific notations is so helpful. Let's recap. We use multiplication when something repeats many times, like seconds or days. Multiplying in scientific notations means multiply the coefficients, the numbers at the front, and add the exponents. And we have to always adjust our final answer for proper scientific notation form. Okay, you've seen how to use scientific notations to solve problems with subtraction and multiplication. Now it's your turn to decide which operation to use and solve real-world problem on your own. Well, pause the video here and try it on your own and come back and see the answers. Well, welcome back. The sun produces 3.8 times 10 to 26 power watts of energy. The question is, how much energy does it produce in 10 seconds? Take a second to think. The sun produces 3.8 times 10 to the 26 power watts each second. We want to know how much it would produce in 10 seconds. Ask yourself, is this a comparison or total that repeats? Since energy is being produced over and over each second, we're finding a total. So that means we will use multiplication. 3.8 times 10 to the 26 power multiplied by 1 times 10 to the first power. Again, we're going to use our rules for multiplication. We're going to multiply our coefficient, and then we're going to add our exponents. Final answer is 3.8 times 10 to the 27th power. Let's recap what we learned. Scientific notations help us describe very large and very small real-world quantities. You can combine all operations to solve practical problems. Always include units and simplify your results. Let's talk about when we add and use addition. Addition represents putting the groups together, combining separate amounts into one whole number. So in scientific notations, this means you have to add the coefficients only if the exponents match. Otherwise, rewrite one number so it's the power of 10 are the same. So when we're subtracting, we use subtraction when you're finding the difference between two quantities, how much larger, further, or older one is compared to another. Finding how much further Jupiter is from the Sun than Earth involves subtracting the two distances. Subtraction shows change or comparison. So when do we use multiplication? Use multiplication when something repeats or scales up. For example, if a computer performs 3.5 times 10 to the 9th power operations every second, and you want to know how many in one day, you multiply the numbers of seconds in a day. Multiplication replaces repeated addition. Instead of adding the same numbers over and over, you find the total faster by multiplying. In scientific notation, when we're multiplying, multiply the coefficient and add the exponent and then fix it to make sure it is written in scientific notation. So then when do we use division? Use division when you're finding how many times one quantity fits into another, or when you're breaking something into equal parts. For example, if we're talking about the virus that is 1.2 times 10 to negative 7th power long, to find how many viruses line up across 1 meter, you divide 1 meter by the length. So then why use division? Division shows how many of one thing make up another, or how much fits in each piece. So in scientific notation, divide the coefficient and subtract the exponents, and don't forget to make sure that the final answer is written in scientific form. So final summary is when you're combining totals up separate amounts, when you're subtracting, comparing, or find the difference, when you're multiplying, find the total from something repeating, and when you're dividing, find how many fit in or how much each part is. Before calculating, and pause and ask yourself the question, am I combining, comparing, or repeating, or splitting? And finally, before you start calculating, pause and ask yourself a question. Am I combining? Am I comparing? Am I repeating, or am I splitting? The answer to that question tells you which operation to use. Awesome work, everyone. You've made it through all 4 parts of Scientific Notation series. If this video helped you, give it a like and hit subscribe and turn on the notification bell so you don't miss our next math series. And as always, remember, learning math takes patience, practice, and perseverance. I'll see you next time. Keep learning and keep growing your math confidence.